Spider, even those that are, we would term aggressive, they're often aggressive because they're displaying.
Okay.
Right? And rattlesnakes are doing the same thing, right? That's the whole purpose of the tail is they do not actually want to strike you. They're trying to say, just leave me alone, just leave me alone, just leave me alone. You don't want to mess with me.
And this is Changing the Narrative. I'm your host, David Rives. We are changing the narrative every day because the narrative has been set, but it's a false narrative, a narrative that we are nothing more than cosmic accidents, the result of star stuff, that we have no purpose in life, that we're simply happy accidents with mutations that have accumulated over the years. We are changing the narrative. We're going back to the truth. We want you to know that you were created in God's image, that you are fearfully and wonderfully made. And today we've got kind of a really interesting topic. It's going to be interesting for some of you guys and horrifying for some of you because my guest, David, tell me just a little bit about yourself. What is your topic of research at the moment on?
Well, it's a pleasure to be here. So,
thank you for being here.
I study right now. I've been focused on studying arachnids, spiders in particular. Have been a passion of mine for several years now. I've done everything from studying black widow venom and black widow silk. Now I'm doing some invasive spider research where there's an Asian spider that's come over in Atlanta, and we're tracking its spread to see if it's messing with the ecosystem at all. Wow.
Okay. Tell me, let's back it up just a little bit. Dr. David Nelson, give me your story. Give me your story, how you got interested in studying these things, kind of the progression. How did it all happen?
Well, yeah, we have to go way back.
Okay. Well, that's good.
I remember as a 4-year-old, I remember loving animals, and I would go to church, and I would introduce myself as like a spider monkey, and that was because my mom had taken me to the library, and I'd picked a book on spider monkeys, and the next week we'd gone back to the library, and whales were my new thing, and so I'd go in and say, no, don't call me spider monkey anymore, call me whale, call me dolphin, something like that. So I've just been in love with animals my entire life, and I felt that once I got to college, there's, if this has been something that has been consistent, a theme of my life, a drive in my life, maybe that's something that God has placed on my heart. Yeah. So I wanted to pursue it. So that's where I pursued biology and ended up falling in love with kind of the small things in biology, and especially the really, really strange stuff, things that were fantastic and outside the norm, like not mammal, right? So that's kind of what drew me towards spiders, was that they're just so different than anything, that we see in our everyday life, and when you really get to study them and look at how they survive and do their thing, they're just fantastic.
They are unique creatures. Now, so I'm admitting to the world right now, I have a little bit of arachnophobia, just a little bit, maybe unhealthy, but I'd like to say not too bad. However, let's talk just a little bit about spiders and the purpose they serve within ecosystems, right? Yeah. Because they are keeping insect populations down.
Yep.
So tell me a little bit about that.
Yeah, they're the number one predators of other arthropods, right? So without spiders in the world, I like to tell the people I talk to convince them of their uniqueness and coolness and necessity is without them we wouldn't have food, because you would have all those pest organisms that would eat crops, and spiders are removing a huge amount of that from the ecosystem to keep it in check, to keep balance.
Nice.
So they're really, really crucial for as arthropod kind of like gatekeepers, and they, when you remove them or when you lose them, you're going to have a increase in all those kinds of herbivorous insects that will kind of denude plants and things like that. But with the spiders there, you have balance. And that's what we see kind of all over the world, is we see this carefully crafted balance. And yet there are a lot of people today that look at that balance as purely accidental. Yeah.
I tend to see design within that.
Yeah, for sure. I think that, a good way of thinking about it is when you take an engineering perspective, right? One of the things that you would want in a system is a system that is sustainable. And that's what we see within nature. It's got self-correcting mechanisms. So if something becomes too little, there's a response to it in the environment that tried to raise it back up. And if something starts to overpopulate, there's a decrease mechanism, and you have this balance. And I really think that kind of speaks to an engineering principle. And
yes, it does.
That then kind of leads us back to the engineer.
Right. Who is that engineer? Who is a divine engineer that has crafted all of this in such a way that it all works together? And for the most part, it works pretty well.
Yes.
But then again, there is, and I'm going back again to a biblical principle, there's a dominion mandate. And that means that we should be looking after nature.
Oh, absolutely. Yeah.
And that's one of the things that you're actively pursuing right now, is looking after nature by studying an invasive spider species that has taken over a particular region to say, well, is this healthy? Is this hurting the environment?
Yeah.
What's going on here? Go over a little bit of that, and then we'll back up and continue with the rest of your story.
Yeah, so the project that we're working on right now, anytime you bring in a species from somewhere else, an introduced species, you always run the risk that the balance of the ecosystem will be upset, because in its native range, there is that balance. So you have this organism occupies a place within the ecosystem.
Okay.
They eat things and then are in turn the food source for other things, right?
Gotcha.
You transport that to a new location, and what's eating it? The predators that are in that location, or the things that would be meant to keep it in check, don't recognize it as a food. It's nothing that they've ever encountered before.
Okay.
And so even if that organism isn't necessarily like directly causing harm, it could still, nothing is balancing it. There's no counteracting mechanism to it. So it continues to, grow and reproduce and reproduce and reproduce. And so then they start to take over. And that might be what we're seeing with this particular spider, is nothing has kind of cued in on it yet to eat it. And in the areas like north of Atlanta and around the Atlanta area in Georgia, where it has been introduced the longest, it's the dominant species that you see. When you go out, you'll see 15-to-1 that compared to any other native species.
Is that right?
Yeah, so they're everywhere, and they're expanding their ranges. We've been watching them for a few years now, and we can see that they're progressively spreading in all directions. It looks like they're spreading maybe a little bit north faster than south, but there might be some weather reasons to that as well.
Yeah, I suspect. Okay. When did you first notice them?
So they were first described in 2014 as being introduced.
Okay.
And then in 2015, the paper by the people who kind of first noticed them came out, and that's when I kind of found that paper. I just recently moved back to the south from California. Okay. And I kind of got excited about, I want to see this spider. This is strange. It's really, really big orb weaver. They're called golden orb weavers. Orb weavers. Their silk is gold colored. Wow. And they're very large spiders. Okay. So my in-laws were from that area where they were first introduced and first described, so I'd go down there and try to find them. And for several years, I couldn't find any. But then all of a sudden, I went one time around Thanksgiving, and they were everywhere. Really? And so then that really was like, okay, this isn't just a novelty. This might be an actual problem. And so that's what started the project to begin to kind of...
In this whole region, I know over the last few years, we've had brown marmorated stink bugs, basically, that are encroaching southward. I think they were first found in Pennsylvania after a shipping container from Asia, was dropped off, whatever. And all of a sudden, they saw the same thing, that they had no real natural predators, that their ecosystem just, they were thriving. Yep. Is this kind of the same situation? Was it potentially shipped over in a package, or do we know how they got introduced?
We don't know for sure, but the shipping container scenario is probably the one.
I got you.
It's the most likely story. Also because where they were first found, we know that there's like a railroad system that goes through and containers are coming in. Oh, yeah. And also the genetic works that have been done on these spiders so far kind of suggest that they came from China. Okay. They're most similar to a Chinese population.
Now, you said the web they weave has a sort of a goldish tint. Yeah. Describe the spider itself. It's a fairly large spider.
Yeah. So as far as I guess on my hand, it would probably take up the majority of my palm.
Wow.
So it's a pretty big spider overall.
Okay.
Very, very beautiful. It's a very colorful spider.
Yeah.
When they're fully grown, the legs will either be solid black or banded black and yellow.
Okay.
And then the abdomen has got silver and yellow bands on it. And then on the underside, the ventral side of the abdomen, there's a big magenta or pinkish patch to it.
Is it?
So
really?
very colorful, very beautiful spiders.
Yes. Yeah. Now, there are types of those orb weavers, or the ones that do the little zigzag shapes.
Yeah.
I've seen for years and years. This is a variation of that, basically.
Yeah. So orb weaving spiders are one of the most diverse families of spiders.
Okay.
They're certainly one of the most diverse of the web builders.
Yes.
And there's all kinds. They range in size from incredibly small, dot at period at the end of a sentence kind of small, all the way to this size where they're very, very large.
Really?
Yeah. And
now, are they aggressive, or what's their behavior?
my experience, they are very, very timid.
Okay.
So if I disturb their web and kind of searching or going through the brush to find them, their response will be flee. Like
okay.
They'll run away to a high spot in their web, or towards where they've got like an attachment point for vegetation. So they'll run up to a leaf and hide. Okay. Or if you continue, they might drop from the web and kind of curl up and play dead on the ground, hoping that you can't see them anymore.
Really?
Yeah.
Interesting.
So that, in my experience, again, most spiders, that's their typical behavior.
Right. Yeah.
In fact, they can be so skittish. There's one where, because I'm going out and doing all these surveys now, your shadow passes over it and it just jumps out its web and falls to the ground. So I have to be real careful because I want to get a photograph of it to not let it know that I'm there.
Yeah. Just before you got here today, you drove up. You gave me a text and you were like, yeah, well, I'm here, but I'm not here because right now I'm walking through the woods, crawling out, trying to find spiders and take pictures of them. You do this in controlled situations where you can document the surroundings, where you can document how many spiders were spotted in a given time frame.
Yeah.
Explain that to me.
Yeah, so we want to be able to say, we want to see if there's a pattern, emerging, right? So if we're going to try to show that these spiders are causing a problem, we want to show that where they're found, we see a decrease in the diversity of other spider species, the native spider species. To do that, we want to kind of have control groups. So we'll go do surveys around Atlanta and where they're found and have been found for several years now. And then we want to control, so we'll come to a place like Knoxville or Nashville or Dixon.
Yes.
And we'll do some surveys up here where they haven't really been seen yet. And if we look at who we're seeing in both locations, they're close enough geographically that they should be similar communities.
Okay.
And then you can compare and say, okay, when they're present, we don't see these species, or we see fewer overall. Okay. And then when they're not, here's the true diversity that we would expect to see.
Right.
So I was, go out and I'd go for a walk for 10 minutes. So I find a spider, start a timer, and then I've got 10 minutes to take a slow walk and search for all the other spiders and photograph them that I can find within that time frame. Okay. And I just do that over and over and over again in lots of different locations. Hopefully I have enough sampled where you can see a signal, because there's, a bit of noise in this process. For sure.
But eventually, if you do that enough times, you may see a pattern emerge. Mm-hmm. Okay. Go back a little bit in your story. Mm-hmm. You said you spent a lot of time in California. Talk about your schooling for a little bit and kind of how you got to this point.
Sure, yeah. So, fell in love with animals pretty early, and then I ended up going to college and deciding what to major in. So I graduated from the University of Tennessee, Chattanooga. Okay. And with a biology degree. Okay. And then I took a little time off to figure out, what I wanted to do, and ended up going to graduate school in California at a place called Loma Linda University. Okay. Yeah. And I was able to study in a lab that focused on rattlesnakes and venomous animals. Wow. And some of the people in the lab had just come in, had begun to diversify into different types of venomous animals. So there were some people who were doing centipedes, and people who were doing scorpions. And so when I approached the professor, I was like, well, what about spiders? Yeah. And he was like, yeah, that'd be great. We don't have anybody doing spiders. I was like, okay, that could be me. So yes. That's how I ended up in Loma Linda in that particular lab. And I studied black widows. Okay. And I looked at how do these animals make decisions about when to use venom and when not to? What kinds of control do they actually have over the use of their venom? Because we've known from rattlesnakes that they will dose the amount of venom that they deliver.
Right.
So if the prey item is bigger or smaller, they will give it a dose appropriate for the size of the prey item that they're trying to subdue.
Okay.
And dry bites are very, very common. Right? So just because something strikes at you or stings you doesn't mean actual venom has been transmitted.
Yes.
So we were wanting to look at that in arthropod. So that's what I was kind of focused on for with the black widows. But there were some other things that I was able to do too. So I wanted to compare male and female venom to say how do they differ, because across venomous animals, the sexes might have different venom profiles.
Oh, okay.
One of the things that's interesting about black widow venom is they have 7 main toxins. 5 of them are specific to insect physiologies. So if you were to have that particular toxin in your body, it shouldn't do anything to you, because you don't have the right, it wouldn't bind to your receptors in the same way.
But for insects, it would be potentially deadly.
Exactly. It would paralyze them. It would mess with their kind of nervous system.
Yeah.
It also has 1 crustacean toxin and 1 vertebrate toxin, and that's the one that when a black widow bites somebody is causing all of the damage.
Okay.
As far as we know.
Okay.
So I was thinking, why would there's a huge difference in size between a female and a male.
Right.
Males are very, very tiny in this particular species. So what would a small spider that probably would have a hard time biting a mammal of any kind, why would they have a vertebrate toxin? And so that's one of the things I wanted to investigate was, are they even producing it? Or is this something that is really just a female specific thing?
That's a good science question. I mean, that's a great question to ask.
Yeah.
So, like you said, we know in rattlesnakes and other creatures that they can dose the amount delivered. Did you find the same thing for spiders?
Yeah, we did. We found good evidence that they can control whether to deliver venom or not. So that's kind of the first level. Is it going to be dry or not? Okay. And then when they decide to deliver venom, they will control the amount depending. And in my particular study, it was based on perceived threat. So how dangerous is this situation? How stressed am I? Okay. If the stress increases, they will deliver more venom in response to that.
Really?
Yeah.
Because in some situations, they're having to make these kind of choices in a very short period of time, too.
Yes. Mm-hmm. Yeah.
Okay, so that's super interesting. We know that there's an advantage to creatures to be able to do this for predatory activity, for food sources, right? But we find the same thing is if they feel or perceive danger, they're obviously going to try to protect themselves by paralyzing whatever is causing the problem. Is that the case?
Well, defensive use of venom is kind of a strange scenario, really.
Okay.
Because for a spider, let's just take a spider example. How do they deliver their venom? Well, they've got these little fangs in the front of their face, right?
Yeah.
And that means that in order to envenomate, they have to get their most vulnerable part onto the thing that is attacking them. Right.
Oh.
So as a strategy, that isn't a great strategy because no venom is so fast acting to instantaneously paralyze. There's always a little bit of latency between when the envenomation happens and when if it's a neurotoxin, when paralysis sets in.
Sure.
And in that time, if it's long enough, you could have retaliation.
Okay.
So that spider is in danger.
Exactly.
So one of the things that we tried to do in our experiment was to show that venom use is like a behavior of last resort.
Okay.
They're not going to use it very early. They are reserving it for only when it is the most dire situations.
Yeah.
And that's what we were seeing with those dry bites or not,
And that's one of the first things you mentioned when I started talking about spiders is what is their behavior? Normally, they're going to try to get away. They're going to try to run. Yes. They're going to try to play dead. They're going to, for the most part, a lot of spiders are taking that sort of action as a last resort.
That's right. Yeah. So a spider, even those that we would term aggressive, they're often aggressive because they're displaying.
Oh,
right?
Okay.
They're trying to warn you, don't mess with me. They're giving you a chance to stop before anything escalates.
Okay.
And rattlesnakes are doing the same thing, right? That's the whole purpose of the tail is they do not actually want to strike you. They're trying to say, just leave me alone, just leave me alone, just leave me alone. You don't want to mess with me. And if it persists, then they'll resort to striking behaviors.
I got you. I was on the Natchez Trace, which is a local,
yes,
a beautiful road that goes through here, and a lot of bicyclists, a lot of motorcycles, you know, very few cars. A lot of wildlife.
Yeah.
You'll have mule deer.
Stopped.
Okay, yeah, it's beautiful. But I was on the trace the other day and saw a massive rattlesnake in the middle of the road, and everyone was slowing down, looking at it. It's just in the middle of the road. Yep. Yeah. So they have their own ways to display and to say stay away.
That's right.
But then you were mentioning, I can't remember, it was like a whip spider or something you were talking about that has this unusual way of fighting or showing its authority over another one of its kind. Explain that to me. Yeah,
so it's actually common for animals, even in like confrontations with each other for access to females for reproductive scenarios, that, you know, there's, you think of the examples of like bull elephants or, you know, bighorn sheep or something, butting heads, these violent events. But for the most part, they want to avoid becoming hurt.
I got you.
And so if a male is clearly larger than another, the smaller male will just back down, and it never escalates to the point. It only escalates to the point where they're butting heads when the two males can't tell the quality difference between each other.
Okay.
Right? You see the same kind of things in these whip spiders, where they will use their pedipalps and they'll stretch them out, and that's the first kind of, right, whoever's got the longer wingspan, the longer arm span, that's the higher quality male. Right?
Okay.
But if two males are relatively close in length, then they'll resort to taking their kind of really long, spindly legs that they use as antenna.
Okay.
And they will wave them over each other. And there's a particular spot on their body where they have these stiffened hairs, and they're waving it right over that spot because they're trying to overwhelm the senses, because these hairs are connected to a nerve. And every time that hair wiggles, it's sending a nerve impulse.
Yeah.
And so they're kind of gauging each other's, like, how long can you keep this up? And the longer they can keep it up, that's the higher quality male. So,
it's fascinating.
yeah, it's a strange world.
It is. It is. Okay, so you are currently in Chattanooga.
Yep.
Are you teaching?
Yes.
Okay, tell me a little bit about that.
Yeah, I work at a small liberal arts college called Southern Adventist University. It's a Christian college.
Okay.
It's in just outside of Chattanooga, just a little bit north of it, between Chattanooga and Cleveland, Tennessee.
Oh yeah, I've been through that area.
Yeah,
before.
Lee University is another Christian college in Cleveland.
Yeah.
So I teach biology courses there.
Okay.
Right now I'm teaching general biology, animal behavior, and an intro, like, freshman class. So that's what I'm teaching this semester.
I gotcha. Now, what is your favorite topic? Or is it all, like, are we talking about spiders right now, or do you teach a broad array of things?
I teach a broad array,
okay.
But definitely, if you ask my students, spider examples are going to be the thing, you know, like, that's what they remember. They know that I'm going to talk about that and use that as an example.
That's the go-to.
Yeah. I mean, well, you know, you spend so much time studying them and with them, you know, they tend to be the thing that you can draw upon to illustrate a concept.
Yeah.
So, but I like teaching. I teach a class on venom and poison because of the work that I've done in the past. And then I teach the animal behavior class. And recently I've been able to teach a class on philosophy of science, dealing with creation, evolution, and integration of faith and science issues.
Yeah.
That has been so much fun.
I bet it has.
Yeah.
I bet it has. Tell me just a little bit about venoms and toxins and all of that from a creation versus evolution perspective.
Sure, yeah.
Can you touch on that?
Oh, absolutely. Yeah. It's actually one of my favorite examples, because venoms are a really interesting thing, right? So we know organisms have changed through time. They do change to an extent,
sure,
right? The question that we are wrestling with is how much, like, and how does it really happen? Like, what is really going on here? And I think venoms offer a really unique window into answering those questions, because if you look at most venoms, you can see that they trace back to just a normal physiological substance, right?
Okay.
So an example would be in rattlesnake venom, you have something called phospholipase A2, right? So it's just an enzyme.
Yep.
And it's responsible for digesting a lipid,
Okay.
a portion of your cell membrane, and it releases that, and that acts as a second messenger. So it's part of cell communication. It's just a normal physiological enzyme.
Yeah.
Right? Everybody uses it. Your body is using it right now.
Okay.
Rattlesnakes have taken that, and now they use it to disrupt the membrane of a cell. Right?
Okay.
So if you look at how and maybe I'll give you a different example to illustrate this, but if you generally, the trend that you see is take a normal physiological thing, chop it up, and overall reduce its complexity, and now that becomes the venom. Right.
Okay.
So the flavor of evolution, or the flavor of change that we're seeing, is a reduction in complexity, not all of a sudden something new is showing up and you're creating something from nothing, so to speak.
Right.
Everything has a base.
Everything has a base. So you're saying it, in most cases, it appears to be something that is pre-existing, that has either taken on a slightly different shape, or it has been reduced in, whether you want to say complexity or not, but it's been reduced to a point where it's being used for a different purpose.
Yes.
And sometimes those purposes can be things like toxins, venoms, things that would be harmful.
Sure. Anything that disrupts physiology, right?
Okay.
And the thing that you're trying to subdue for food would be a good venom, right? That's what a venom is. So a good example to illustrate this is something called a snake venom metalloprotease. So we call it SVMPs, snake venom metalloprotease. Its normal physiological thing is called an ADAM, a disintegrin and metalloprotease, and it's just a normal enzyme. When you compare the atoms with the snake venom metalloproteases, you very clearly see that you have deleted a bunch of stuff to get to the snake venom metalloprotease.
Okay.
And now that thing is just a digestive enzyme. You know, but you can very clearly see how you've lost information to get there.
Interesting.
So loss of function is one of those things, right? So like polar bear is an example, right? They're grizzly bears, but they have loss of function mutations. The same thing happens in vampire bats, where you get this switch from probably being sugar eaters, pollinator kinds of things. And then you have the reduction in the total like enzymes, and now they're blood eaters, blood feeders instead. And so you have a loss of function mutation that can explain that.
Loss of function, but fulfills another ecological niche.
Right.
It sounds like great engineering principles at play.
Sure, yeah.
Dr. David Nelson, thank you so much for being here with us today and sharing this. Even though it's a topic that I'm not the most fond of, I found this absolutely fascinating, and I think our viewers did too. So thank you again. And thank you for joining us. This is Changing the Narrative. I'm your host, David Rives. Remember to keep looking up, because truly, the heavens declare the glory of God. Find us on all social platforms to stay informed. Watch Genesis Science Network 24/7 for free on Roku, Fire TV, and on our website.